Hello, hello. Real life? Yeah. Alright, I see us, and I think I hear us. Pana, say something, please.
Hello, everyone.
Okay, I got your audio. Alright, so,
Okay.
yeah, we should be all set and good to go. So, yeah, good morning, good afternoon, good evening. I'm going to pull back my music a little bit. There we go. So yeah, thank you for joining us here at Coded Live. As you know, this is our channel where we are passionate about a lot of different things throughout the week. We do CMS and podcasts on Monday. We do React and UI on Wednesdays. Thursdays is .NET and Xamarin. Fridays is a chat show. But today is Tuesday. And today's going to be super fun. Today's our Unity Tuesday. And we are actually planning on going a little longer than what we normally do. We try doing an hour, but you cannot accomplish a whole lot in an hour, so we'll try to go a little long today and try to really build some stuff. So I'm Sam Basu. I'm a dev advocate here at Progress Software, and with me I have my good friend Pana Kankov. So hello, Pana.
Hello, Sam.
All right, I think your microphone is still okay. I'm hearing you good, so we should be all set. So just for context, folks, this is Unity Tuesday, and you likely, if you joined us the last few weeks, I started out with knowing absolutely nothing about Unity, and Prana painfully sat through as I tried learning some things. It's a lot of fun, like coming from like a mobile and a web background, the things that you can do with Unity, the physics, locomotion, lighting, camera, this is all just fascinating to me. So I've gone to a point where I at least understand what's going on, but then we have switched from last week to a mode where you're actually building something in VR in Unity. So we have a big conference that we put together called DevReach, and obviously this year is going to be interesting. We have plans on exactly how we want to do things in DevReach, which we will announce in probably hopefully a week or two. But then we are planning like a social event that kind of goes along with DevReach, where people can put on their VR headsets, any type of VR headset, because this is done in Unity, so we're not tied to any platform. Or you can also be on your desktop in a 2D environment and just be able to move around. So with that, we are trying to build a VR world for DevReach as a conference, and I think we are going to choose our office, which I absolutely love. It's our engineering headquarters out in Sofia, Bulgaria, and I know like Prana and everybody else that I talked to, like it's fine to work at home, but everyone's just itching to go back because it's so beautiful. Like the mountains are right next to it. We have an absolutely amazing game room, so we'll try to recreate a little bit of that. Right, Pana? So, yeah, it's up to you. And you're folks looking at Pana's desktop, and we are going to be building stuff in Unity, and then when it gets to scripting, Pana, I think I'm all set up on my end. Maybe not today, but like even eventually, if you want to do a live share, I mean, I can code on Visual Studio as well on my side, so that way we can both collaborate. But the floor is all yours.
Okay, that would be awesome.
Yeah.
So this is where we left last week.
Well, it's funny. When I say the floor is all yours, like you literally start with the floor.
Yeah, all we got is a floor. So yeah. We had a little problem with this floor. Now we want to build a space, but we are not yet sure how exactly it will look like. So let me show you something. We have a little video,
nice.
360 video of the office, so we can take a look around.
Wow.
And we want to build something similar in VR. We want to use to share some of the elements that will make the VR world feel like home, but we are not going to create a photorealistic copy of this.
That part, by the way, is my favorite part. Like we have these interesting like pieces of like structures that are just lying around. They just kind of elevate the space. And then I'm big into ping pong and table tennis. I love playing table tennis. And what you're not seeing is like across from those windows on the left, there's a beautiful balcony that looks out into. Yep, there you go. That looks out. It looks out on the rest of the city, and then the Vitosha Mountains in the background. So it's an amazing space.
For now, we are not allowed to go to the office, but I hope that I can sneak in to take some 60 photos for the environment background.
Sure.
Yeah, fingers crossed. Okay, but for now, you can see our floors in the play area a little bit everybody, and we'll have to take care of these elements here. Last time we just used a plane, but there is a problem with the plane that you cannot scale it very well. I mean, if you want to make a space larger, you can scale it, but then the texture scales as well. So we were thinking with Sam that maybe we can create some of the office elements with code in a way that we can position them and resize them, and that will allow us to model the space. So let's start with the floors.
Yeah, and before you start, I see our good friend Ivana in the chat room. Good to see you, Ivana. Here's another person who goes to the same office, and I'm sure she's missing being at the office. So yeah, that's what we're trying to do, creating a VR space. And these floors, Pana, like these were like mesh elements, like they were textures, right, that you associated with those planes?
Yes.
Okay. Yeah.
So
and
we have this is a plane. What you can see here is if I enable shaded wireframe, you can see how everything is divided in triangles. These little triangles, this is the mesh actually. So at every corner you have a vertex, and several vertices are combined together to make a polygon. And they have the information about what part of the texture is positioned on that triangle, and how it affects the lighting. There are things like you will see a little bit later.
Yeah. So two quick things. Ivana, while you're in the chat room, let me know if this if the background music is too loud. I can tune it back a little bit. And then one question I had for you, Pana, and I know we were dealing with this the last week when we were doing this. So each of these are just planes that you are bringing in, and even though you lay them side by side, they are not. Oh, that's you, right? Far side.
Yes.
Okay. Oh yeah. So you can totally mess up our screen. I mean, not mess up, but it's all interactive. So all your emotes, all your emojis, they can fly around. So just be careful. Like with power comes responsibility. Right. Okay. So even though these planes are side by side, like Unity would not let an object just like cross over, right? From one plane to another?
They can cross over. For example, I can show you this. You can basically do stuff like that, and well, they cross over badly.
But if you had, so now you're actually tilting the plane, but if you had like a ball or like a person, like could they like move from one plane to another? Because I think that's where like locomotion comes in, right?
Yes, they can walk from one plane to another. There's no problem with that. So you can see there is a mesh collider. This mesh collider basically tells Unity when it's using physics to use these polygons when it does collision detection. And when they are well aligned, if you have a ball, for example, on this plane and push it toward the other, it will not fall in between. I mean,
I see. So, I mean, if there is no collision, it will roll.
Yes.
Okay. All right. And while we're going, looks like Ivana has found that she can drop chickens, and yes, the chickens will fly around. So just don't drop too many chickens, Ivana. That's going to fill up our screen. All right.
Okay. So I have imported several things in the assets that we will use later, but let's start with the flows. This is like already have a scripts. I'm going to create something called flow surface, for example. This is mono behavior, and I'm going to create this mesh dynamically. It will allow me to edit the UV coordinates in a way that I will be able to change the shape from, for example, from square to rectangle, but it will calculate the UV coordinates in a way that they will preserve the size of the texture here.
Interesting. So this I know now, because this is what I was learning. Like when you drop scripts, you essentially get the update and the start functions. I mean, there are other functions you can tap into, but those are kind of entry points where your Unity engine comes in and executes some code on your behalf before returning the control back to Unity.
There are a lot of functions that you can control, and there is this complex graph here that lists all of the events you can plug into. So we can just use the start and I think the update, and there are a lot of going on in between. There are things that are triggered by the animations, by the physics engine. You have the fixed update here. As you can see, fixed update can happen several times per update if the physics decides so.
It's quite fascinating. Like I remember asking you like the difference between like the fixed update and the late update. It's a lot of control on exactly when you want to have your code executed.
Yes, and it matters a lot.
Yeah.
Okay, so I have created a new game object, flow surface. I'm going to attach my behavior, and we're going to edit it. Now, you can actually execute your code right inside Unity. What do I mean? We want the flow to be configured.
Pano, one quick thing. Could you bump up your fonts just one size, please?
Maybe I should. Yeah. Okay. So how is it now?
What did you change?
Is it okay?
Maybe one a little bit bigger.
I'm sorry. It's set on maximum at the moment. Maybe I'm talking.
No, not your sound volume. I meant your font size in Visual Studio.
Font size? Oh, yeah. I hear a phone, not a
font.
Sorry. Okay, that's perfectly fine. Okay,
yeah, perfect. Thank you. That's way too big. So you can go down a few fonts if you want.
Okay.
Yeah.
Tell me how it's fine.
Yep.
Like that?
This is fine.
Yeah. Okay. So we won't have of the float. Normally you can go for width and height, but height will make it go up, so I will go with width and depth. And these are private fields. They cannot be changed at runtime. If I make them public, people may go use the code and try to set the fields and expect them to update, but they will not. And currently, because they are private, they will not appear in the inspector. But Unity has a control to show them.
Can I ask you, like, why are you trying to change the way the hexagons are drawn?
Because currently, if I want to make a big room that will accommodate two table tennis tables, I can only affect the scale of these polygons. And
I see.
And what it happens is the floor is stretched. I mean, these are no longer rectangular patterns on the floor. So what I want to do is to make something that will grow the shape, but will preserve the texture size.
Like the fidelity. Yeah, I mean, this is like the classic thing with like vector graphics, right? I mean, when you stretch, you need something that stretches with it.
Yes. Okay, so here's the question. We will want Unity to show us a preview. So I'm going to of my lifecycle methods in the editor. When you're at executing edit mode, start is called once when you're in the Unity editor, and update is called every once in a while.
Wait, this is interesting.
Yeah.
What does that do again? Like it calls update not every frame?
Yes, but this is only in the editor. I mean, when you're clicking the properties here, it will call update after you change the properties or after you move an object.
Sure.
Yeah, and so a nice place to build a mesh actually and show it in the editor. When we are executing the application at runtime, we will not change it in every update. We will make it just once on, for example, on awake as early as possible. So let me add the build mesh.
Okay, I have a dumb question, but once you're done writing that piece of code.
Yeah, go ahead.
So the floor, the mesh that you brought in for the floor, could you show me like the asset? Like what was it in Unity?
The asset? In the asset, what we did is we right-clicked to the object and created a plane.
Yep.
And these planes have a static mesh. This mesh is about 10 by 10 meters and have UV coordinates that go from 0 to 1, from one edge to the other.
Okay, so this is what I was going to ask. Like, if you chose a mesh that was like big enough, then would you have to do this? Oh wait, maybe Pana, move a little closer to the camera because your face is getting a little cut off sometimes with the green screen. Yeah, now that's better. So, like, would you have to do this? Like, if you chose a floor mesh that was like big enough for how much you want to stretch it to?
Yes. Basically, you can create this in something like Blender and design a floor that is big enough. But then we will not be able to change the layout in Unity. It will be like set by a 3D artist, and it is what it is. I mean, once you build it, it's pretty much fixed in size.
I hear you.
I wanted to make it dynamic because in the course of the next few weeks we will be adding small spaces and grow the environment.
Got it.
Okay, so we can create a mesh, but how do we do that? Just like that. After we create the mesh, we have to make this rectangular pattern. The mesh has several fields that we can set. One of them is the vertices. This is array of three-dimensional vectors, and instead of making so many polygons, we will just create two. Like there will be two triangles. So we have to get the coordinates of the top left corner, top right corner, bottom right, and bottom left. I'm going to help myself here with okay. Because I will need to use this a lot. And I'm going to populate the vertices. So
You're just so used to using F that like desktop and mobile devs almost never use the floating F.
Normally I don't use it, but since we are dividing here,
Yeah.
if this is an integer,
You want the precision. Yeah.
Yes. Exactly. So this is.
Yeah. I have one more question. So, like this stuff that we're doing, I mean that is specific to that one plane, right? So would we?
No, you can create dynamically a lot of other shapes. I mean, currently we'll be building a mesh that is a plane, but there are things like text rendering that compose similar similar planes to lay out letters and display them in the 3D environment. There are other ways to, other reasons to build a mesh dynamically.
Okay. All right.
So this is going like this. So these are the positions of the vertices in the coordinate system of the object. And now we have to assign it. So how do we assign it? If you take a look here, there is a mesh filter, and the actual plane mesh is set on a property of the mesh filter. So for our object, we'll actually have to add a mesh filter. And we will need to add a mesh renderer. Okay, now that we have added these components, we can get them in code.
Is there a way in which like this rebuilding the mesh, like could this apply to like every plane, or would you have to do this once for each plane?
You can use what do you mean if it is a plane you can use it once for each plane? Currently all of our planes will execute this code and generate their mesh. It's relatively small and simple mesh, so it will not
so maybe that's what I'm misunderstanding. So how would all of the planes generate this mesh for themselves? Like, is that mesh tied to each plane?
Yes. What will happen is after we finish with this float surface here, that's, I don't know why. Oh, just let me position it closer to the other planes. Once we finish building it, we can basically use it as a building block, and we can duplicate it and move it around.
Okay, that's what I'm
and
getting.
And then we can play with the height of the planes, and this will allow us to move blocks around, change their shapes, and basically every plane will be a single room. Normally a room has just a single type of float, so we'll be also assigning materials here to represent these spaces.
Sure.
Okay.
Yep.
So what we did is we created a mesh. We assigned vertices. This this will add the positions of the vertices. What we also have to do is to define triangles from these vertices. I mean, we have top left, top right, top bottom, and that's one of the triangles. They are defined by. If I type 0 here, 1, 2, what this means is that there is one triangle, and the vertices is this one, and that one. Okay. So now we have vertices, we have triangles, and it should show something.
Yep, right there.
Yeah, a little bit broken. There is something special here, and that's which side of the triangle is the front face of the triangle. Currently, I think that one of the triangles is. We broke the math here, so this is the top left, this is the top right. Oh, I think I got this wrong.
Is it like in like XAML or like the older way of building games, like we used to have like 4 things, like it's left, top, right, and bottom? But with the triangle, you have like 6 of them, right? So 6 corners.
So we have 1, 2, 3, 4 corners.
4 corners.
And for some reason, I'm not seeing here the wireframe. But basically, these are the 2 triangles. Now it's rendered using this color because it doesn't have a material. And basically Unity uses this magenta color to show errors with shaders, errors with materials, and everything. Now, in our progress space, we want to build first these 2 areas. These are the part of the game room. So we have a table tennis here with a green floor, and we also have things like darts over there. We will use the blue area for that one. And I have prepared materials that we can use.
Okay.
This is the rubber floor blue.
And what are these materials? Are they images?
Material basically combines together a shader.
Okay.
Several images. Yes.
Okay, so I meant like when you say material, it's a Unity material that you're talking about.
Yes.
Yeah. Okay.
So this is a Unity material that I prepared.
Yep.
It has a blue color and a normal map. This is one of the images that it uses to make this grainy texture on the floor.
Nice.
It will reflect light pretty much like you see it here. So there are several places to assign bitmaps. One is the albedo. Currently it's a single color, but you can click on the box here and drag textures there. If you drag a texture, the albedo will change the color of the object. So if you don't want it to be solid blue, but want to have something like a label, for example, you can create an image with text and assign it here. The normal map is very specific, but it basically controls how the light will bounce from the object. Okay, so what I did is I dragged the material on our surface, and we have a problem now that the floor actually is visible from the bottom, but it's not visible from the top. So we have to reverse the normals. When you are building triangles, there is something that's called winding order. If you go to the edges in clockwise order, then you're looking at the triangle from its face. If you're going to the edges in a counterclockwise order, then you're watching it from behind. So I'm just going to swap the winding order here, and after the unity bits, it should show a floor. Okay, so
Yeah.
what we can do now is we can control the size of basically of a room, for example.
Nice. So that's what the mesh, the triangle thing is doing, or the rectangle is doing. Like it's letting you change that without deforming the mesh underneath.
Yes. And basically, once our code is executed at runtime in the actual game, it will be created in awake once, and it will be static. So you can do similar animations or changes with models, but you have to use shaders that know how to affect the size and the position of the vertices. Now there is a little problem here. It is black. Last time you asked me one simple question: how does the model know how to display the texture? I mean, once you put an image, what goes where? This information is stored in UV coordinates, so we will assign it the UV coordinates here. These coordinates are the position of each of our vectors within the actual image. So also normally they are stored in values that go from 0 to 1. If you're building something like a model, like a human head or something like that, you will have a single image that will be probably square, and each of the pixels in this image will map to a single part of the human model. But in this example, we are building the environment, and we will use stylable textures. So,
Pana, can I ask you one thing? Like,
yeah.
Could you like turn on a light or something in the room? Because like your face, like with the chroma cam, it's growing in and out a little bit. Maybe it's better like if you like sit back a little bit, then it looks like it's doing it better. Yeah.
Yeah, I think it stopped blinking.
Yeah.
Okay.
Yes.
Okay. So this is what I'm going to do. Since I wanted to tile, I will use part of the texture for the first coordinate. But I'm going to use for the top right part, I'm going to give it the width of the plane. So what happens here is 1 meter of space will be basically one texture tile. So if you put an image on the surface like we used to do last time, they will not stretch, but they will rather tile at every meter. Okay, so it should be.
Yeah, I fixed up your your camera feed a little bit, so hopefully it stays.
Yeah, maybe I was too close. Okay, let's see what happens. No, but I didn't save the 0, width, depth. Doesn't seem to be working. Interesting.
Which part is not working? Like the floor as you turn it?
Yeah. Basically, it created correctly the mesh. The size of the triangles are fine. I can change the width and the depth of the room, but it stays black. So I added OV coordinates that start from the 0, 0. This is the like top left, top right, bottom right, and bottom left, and assign this to the mesh.
Yeah, this is exactly how like I'm used to doing things in XAML. Like it's top right, top left, top yeah, right and bottom.
Yeah. Interesting. Okay. So something is wrong here. Let me check it again. Triangle Suez. That doesn't make any difference. Maybe okay, I'm not going to lose a lot of more time here. I just want to check something. This is pretty much the same thing that I tried a little bit earlier, and
Is this stuff?
Oh, I also don't have normals. You know what? The problem is not with the UV coordinates; it's with the normals. Yeah, tell me, is this tough?
No, go on. I don't want to break your chain of thought. What do you mean normals? What are normals?
Okay, so normals, you have the position of the vectors, but if you want to enable lightning, Unity has to know how the light hits the surface and basically how the surface of the triangle is positioned. You may think that you can calculate it from only from the positions, but Unity has ways to create curved models. Like you use 5 or 6 triangles. You specify different normals, but inside these triangles, the normal is interpolated. So you can say, okay, the left corner is not looking up, but it's looking to the left, and the right corner is not looking up, but it's looking to the right. And the whole surface will look a little bit curved. Now, without normals, Unity probably cannot figure out how to work with lights. There we go.
there.
We just told him that everything is facing up, and it now works. Now
Nice.
the whole thing was
perfect.
Now look how does it stretch.
Yay! So cool.
Now,
so cool.
you can pretty much find the difference between these two. Okay, let's assign it with our blue. Okay, there is a grainy surface there.
Beautiful.
And from now on, we will be using these surfaces to model our environment. I'm going to give it something like a reasonable size. I'm going to position it at 0, 0. And now, look what I'm going to do. This is the floor surface blue. No, floor surface blue. And I'm going to drag it into the assets folder. What happened here is this become a blue box, which means that this is a prefab. Now what we can do with prefabs is I can get the float surface blue back from the assets and back into the scene.
Right.
So we can now design as many rooms as we want. You can also copy this. And here is something interesting. If you go to the assets and double click this prefab, it will allow you to edit it in isolation. For example, you can change the material. And when you go back, all of these instances actually know which one is their parent. So they will be affected at once.
Yeah, it's nice. Yeah, one of the Unity tutorials that I started out doing it had me using a prefab. This is nice. Now, go back to your code one more time, please. Like the rebuild mesh, where were you first invoking it?
Okay, so when the game is running, and when I hit the play button or when I build it for local quest, in the wake method, this behavior has enough data. It only needs these two fields to actually build the mesh. And it will call the build mesh method and create and assign it.
Right.
When working with the
No, I mean that should be fine because the only thing I was thinking, like, is there a performance impact on doing this like every time? But it just does it one time and that's it. It's got the mesh for all of the planes.
It will do it just one time.
Yeah.
In the game. When we are running in the Unity editor and change the width or the depth, Unity will execute the update. But this is only on a developer machine, and this is only when you are working within Unity. Yeah, there's one last thing that I want to set on the mesh. Unity will try to serialize everything. So when we are building things right there in the editor, we can tell Unity that they are dynamically generated, and we don't want it to not editable. Okay, so we don't want Unity to offer instruments to the users to edit this mesh by hand. Awesome. So we have the blue and the green area. The green area is actually bluish. We are going to change the texture. I'm going to add it to the prefabs again, but I will not inherit from the blue. I will just create a completely new prefab. Green, okay. And this point, I think we can remove some of these planes and basically build everything with our new floors. This is the center. I can add them here. Okay, so this is how you can create.
Yeah, this is pretty cool.
The floor. I'm going to.
Pana, let's hydrate. You've been talking nonstop for like 45 minutes.
Okay. Okay. How does that check? Okay, so are you there?
Yep, yeah, I'm here.
So this is pretty much how you can build geometry with code, and I've already prepared something a little bit bigger. Now, this has a few more triangles in it, so it also has a height, and will allow us to use it for walls, and it's pretty much the same thing. Okay, here is a support beam. Let me show you.
Whoa, whoa. What is that? Is that oh, it's a cube, but it looks like hollow.
It's cube, but it looks hollow because normally you will have a floor on the bottom and a ceiling on the top.
Yeah.
Yeah, so that's why it's.
How did you take it off? Like how does it look like the way it is?
Okay, so first there is a script similar to our floor surface here that has width and depth, but also has height and chamfer. So basically, you can control this little corner here, and the height of our columns is
What
I
is
think about
chamfer? Sorry.
It's when you have a straight edge and you cut it a little.
Okay.
This is how the columns look. Basically, this little here,
yes,
this little
yes.
thing here is the it's a nice detail.
It is.
And it also has a concrete material. It has this image of concrete,
Nice.
and basically that's all. We don't have good lighting at the moment in this environment, so it looks really dark. In our office, we have plenty of lights that we are going to add in a second. And hopefully this will become lighter. But here's what we can do.
Okay. Can I ask
environment.
Can I ask one quick question on the beam? What is that? The sign of a light? Like
This is not on the beam. This is an accident. It just happens to be in the same place. This is the directional light.
Got it. Okay.
Yeah. We are going to add a few more lights, but they are not going to be in this thing.
Sure.
I'm going to clone it and create a few more of it. I think in our office space we have some between the playing
Right.
areas that separate them. So I'm going to add a few more. Okay, and maybe I can align them, center them, and okay. Do you feel like we need more, or that should be enough for now?
That's fine. Yeah.
Okay, so just like we did the floor, we also have sailing. It's similar thing, but the normals changed and the winding of the vertices, so you can look at it from the bottom. Okay, normally it would look white, but because we don't have lighting, the only light we have is our sun that's shining from top to bottom. Nobody is adding light to the ceiling. Okay, I'm going to
Well, this is actually quite fascinating to me. Like, you're putting a ceiling on, and then like you have to maybe restrict Unity from ever taking the camera angle to be above the ceiling, right?
Yeah. Yes. Since we're doing this for VR,
sure.
We don't expect the player to be taller than 4 meters normally.
Right. Yeah.
You will not be that tall. We have our camera rig from the last time. I'm going to push it inside.
Yeah. Okay.
Okay, and that's how we can create dynamically structures and change the layout of the space. I think I also have a wall. The wall is pretty similar to...
Could we put the wall at one of the sides here? Exactly.
Oh, you can. Again, it should be... I think it is. It's white. It's relatively white. I'm going to align it. No.
So after this point, Pan, I'm curious to see like how it actually looks like when you put on the VR, like, or you just like go into play mode. Like, what does the camera angle let you do?
Okay, so let's fire the device here.
Nice.
Now,
yeah, you can look at the floor, you can see the shine. Yep.
Yeah, you can see the literal grainy texture.
Yeah.
We have lighting here for the beams here, so you can see the concrete.
Yeah.
And we now have to add lights because we need internal lighting for the rest of the room.
Sure. Okay. Yeah, looks good. Now, where is that one default lighting coming from? Where was that again?
The one default lighting is when you create a new Unity scene, Unity adds the light for you. Basically, if we go there and click create scene, new scene, and save, there is a camera and a light.
Okay. So for us, the light was sitting right like above that one column, right?
Yeah.
Right.
But there are different types of light. This one is directional, which means that this is the sun. I mean, its position in the world doesn't matter, only the direction of the light is taken into account. So even if you put it above or below a surface, it always acts in the same way.
Okay.
Okay. I have prepared some models. When you are working with Unity, you can either go to the asset store and get things like you can basically purchase 3D models. You can look for table, for example, and there will be plenty of tables there.
Are they free?
Some are free, yeah.
Okay.
This is one that's free, and it looks pretty great. Or if you are working with a 3D artist, they'll create the models for you. And one of the formats that is well supported in Unity is Fbx. So I have prepared several simple models that match our office space. I have a hanging lamp and another lamp. So which one do we start with?
Either one.
Okay, I'm going to add the hanging lamp, but let me...
Chat room, you've been quiet today. Let us know what you would like us to do, or if you have strong feelings one way or the other.
Okay, and just like that, you can import an Fbx file. It comes with...
Wait, a what file?
Fbx. This is one of the files that Unity supports. Okay, so if I drag this here, it will import a model of the lamps that we have in the office, like it's hanging from the ceiling.
Interesting.
Yeah. It doesn't come with the light though.
But you have to put the light on.
What I'm going to do is I'm going to add a light. You can go and I think point lights should be good for this one.
What are the differences? Like I see point and area and spotlight. What are the differences? Like how the light dissipates?
Yes. Basically the point light emits light in every directions. A spotlight will be more focused, like it will make a circle on the ground for you. There is the directional light that we already mentioned. It's frequently used for the sun.
Sure.
There are the reflection probes and light probes. These are mechanisms for Unity to collect information at build time about the lighting of the scene and the reflections that it should use, and allows complex light environments to be rendered efficiently at runtime.
Sure.
Yeah. Okay. So we added a light. Since we're going to do this for Quest is mobile, and we cannot add a large number of dynamic lights. So what we are going to do is we are going to use light maps. Unity generates light maps during build time, and basically does something like a physical simulation of how the light will be distributed, and then stores that information into textures. And then at runtime, the objects just check how they should appear by testing the light map texture, and they don't have to calculate rays from the lights. Okay, so for this to work, I need to set the light to static and convert it to a baked light. And I'm also going to make the heading light lamp static.
Yeah, maybe Pana, move back in your seat a little bit. It's doing that thing with your face again. Yep, there you go.
Okay, so this checkbox here for the static objects is very important. Once you mark something as static, Unity will know that this thing will not change at runtime. Things like the environment, like the beams, the walls, the floor, and the ceiling, they are not expected to change. I mean, even if you throw something at them, you would expect it to bounce back. So I have created a lamp. It's casting shadows. It receives light maps, and there is an actual light there that will be baked, which means that at runtime the objects will not be affected by the light, but at compile time Unity will use it to calculate the lighting texture. I'm going to make a new prefab variant, okay, and we're going to add multiple lights. Yeah.
And how are you doing it? Is like mouse or control and then mouse to replicate?
You can hit Control and D for duplicate.
I see.
Yeah, this is a shortcut. We will have to eventually reorder and rename the lamps because currently yeah, okay, this one is the second. Okay, and again.
Can I see it? I mean, you want to put up like VR, but just like show me in play mode. What does that look like?
It's not ready yet.
Oh, wait. You did a trick. So how did you copy all of the, how did you duplicate like all of them all together?
Again, Control and D. It's a duplicate.
Oh, so you selected all of them and then you did Control D.
Yeah.
Alright.
Yeah, you can, if I hit Control and D, it will create a copy.
Sure.
And you have to move it away. If you select multiple things,
creates a copy of each.
Yeah. So just selected them. They should be lower, I think. Okay. We'll need some time to realign them. Okay. And here is the copy. Control and D, and I'm going to move them on the other side of the room. Okay. And you want to see how it looks like now if I click the play button. Maybe I will need to reposition the camera. Where is the camera?
So, down on the green. Yep.
Probably, yeah, it looks well lit. But here is something. Okay, the lights. All lights are baked. Yes, and we're going to do something here for this scene.
So
if you click the
auto
generate, yeah.
Just this quick thing. I mean, folks who are joining us just now in the chat room, we are building a VR world for a conference and just essentially replicating our office in space.
Yeah, we're now dealing with the lighting. Okay, so this is the lighting dialog. You can open it from window. Rendering. There is lighting settings, and that's it. There are a lot of options here about how to bake these light maps that I mentioned, but I will just stick to the defaults for now and hit generate. You see, it's currently doing a simulation. All of the baked lamps will emit vectors with lights. These vectors will hit the surfaces and populate the lightning textures. Then they will also bounce. So
while you're doing that, hey, good to see you, Dead Pixel, in the chat room. What's up? We are, we have moved quite a bit. I remember like one of the days where I was doing Unity and I knew nothing. This is quite a bit different because we are now in expert hands. We have Pana driving, you're looking at Pana's desktop. So we are building a VR world. We are replicating our office and we're dealing with lights. So good to have you here with us. And yes, that Pixel, the emotes do float now. So more control.
Okay, so the directional light will be the only real-time light that I'm going to use in the scene. It will be used for let me show you.
Can I move a little back in your seat, please? The chroma cam is very sensitive. There you go.
Okay, so for these specular highlights to work, you need some sort of runtime light. But if you use too many, the Oculus Quest device will struggle to render them. So normally we stick with one real-time light. And I forgot to switch our directional light to a real-time one.
Okay, I'm a little confused by this. Like, when you say real-time light, like you're putting them on the scene, like are they not like turned on? Like what's real-time about them?
They're not.
Oh, you went off. There you go.
So we have. Okay.
No, you're back. You're back.
Yeah. Real-time lights affect the objects as they move, as the game is rendered, and they're relatively complex and expensive on the GPU.
Yeah, I bet.
Yeah.
So is it like sorry, what were you saying?
Backlights will basically help in generating a light map. So here is what a light map looks like. This is the light in the table tennis area, for example. This is the light on the ceiling. This is the light on the I think one of this is the green and the other one is the blue floor. And they generate these kind of nice shadows by the edges. These shadows cannot be computed at real time because they're expensive on a mobile hardware. Now, we know that you can now run with ray tracing Minecraft and it looks insane, but for our Quest devices, this is the best lighting that we can provide. So we will create a lot of baked lights that will not work at runtime. So if you get an object close to them, the lights will not affect the object, but they will contribute to this light map at build time, and will eventually lit the whole scene. Okay, so you can see parts of the scene are now generated, and you can see the texture of the ceiling.
Nice.
You can see the texture on the floor.
Yeah, I put up what Dead Pixel was trying to explain, which is the same thing that you said. So it calculates the light and shadow while the game is running, and the baked ones is on texture for things that don't move. So that makes sense. Now I had one more question in terms of like when we are looking at this in VR, just to kind of save on like some GPU, like if I'm looking away from one part of the scene, like if the lighting is behind me, like does Unity have the smartness to like turn things off or like kill things that are graphic intensive that I'm not actively looking at and then regenerate them as I turn? Or is it always lit?
Yes. No, Unity is very smart at rendering objects. For example, if you check the camera here, there is a camera fustum, I'm not sure how it's called, this shape, but everything that is behind the camera will not be rendered. So before Unity sends the scene for rendering, it will filter objects that are behind you and will not render them. Also, when you have textures for the objects, you can generate bitmaps. So when the objects are far away, just a small preview of the texture is used for the rendering. It will not allow it will not use the whole texture. And there are a lot of optimizations like this that Unity already applies.
Interesting.
Okay, look what happened. Auto-generated lighting. It's completed now. We will need to probably play a bit with the settings of these objects. For example, currently the lights didn't generate shadow on the ceiling. I think they basically went to the lamp model and illuminated the ceiling. But let's give it a try in VR.
Okay.
Okay. Okay. So you can see now that the white wall ahead of us, for example, has a darker color in the bottom left part and a brighter color on the top right, and for some reasons the floors didn't receive any shadows from the beams, and we have to set the lighting, but I want to add a few more lamps that we have before I start trying to
Can I ask, like,
make it look pretty.
Yeah. No, can I ask, like, if, like, when you look at it, like, I can see the lighting, but, like, where the lights are, like the black lights, like, that part is looking black. I mean, could we make it look like the light is coming from, like, that particular lamp in any way? Do you see what I'm saying? Like, when you look at it, like the ceiling is nice and white, and it's well lit,
Yes.
but the light itself looks black. As compared to, like, if you pull out that YouTube thing that you had, like in real world, you actually see the light coming out from the exact lamp that you put.
Yes. Okay, so we have this point light here that we can control to generate shadows, and you have a lot of options. But on the model of the lamp, we actually have two different materials. One of them is used for the body, and the other one is used just for the inner piece here that is supposed to shine.
Okay.
What I'm going to do is I will get the hanging lamp model. I think I can basically extract the materials. Yes. Okay, so this is a sailing lamp. I'm going to put the materials in a special folder. Okay, go there, select folder. And what happens is now we have control on the materials. With the 3D editing program, you can use materials that are specific for the 3D editing software, and Unity will try to convert the materials as well as possible, but you want this to be white, right?
Yeah.
So we can enable emission on the emissive part. And currently it's very dark, and you can...
Pana, your chroma is making you headless again.
I'm sorry.
Yeah, it's hard. Like, when you're coding, you do want to lean forward. I understand.
Okay.
There you go.
I will try to get used to not leaning forward. It's Scott, but okay, so
Yeah.
here is
Yes, that's
the lamp
exactly what I
looking bright.
wanted. Yes.
Okay, there are a lot of similar settings that we will have to apply before it is ready. Now, this area at the top, if you check the real world, it's not lit. I mean, this lamp shine down, but the light doesn't go up.
Yeah.
And I'm not sure why. So basically the model here casts a shadow and is static. So it should have prevented the lamps, the actual lamps, from... Oh, no shadows. Okay, okay. So I'm going to switch the lamp that I added to actually generate shadows.
Yeah. Maybe that's
and
why
I'm
it
going
wasn't.
to... Yeah, now I'm going to apply this to the prefab that I created, so the change will affect all lamps. Okay, now probably there will be shadows on the floor. The beams should have a lot of shadows on the floor. I want to add one more type of light before we continue. So we have the hanging lamp, and we have one that I like. It's the one here. I think there are a few like it in the office, but
What is it?
over there, let me just add it into the materials. Like this is the sailing lamp. I will add a floor lamp because standing on the floor. Okay. Now I'm going to... Oh, I double-clicked it. It's a lamp like this. But because it has interesting shape, it actually casts very nice lighting on the ceiling and on the floor. It adds a nice detail.
What is this other app?
Other app, you can double-click
just...
3D file in Windows, and it basically opens the Paint 3D. I think it's 3D Paint or Paint 3D. Just let me check. It's built in Windows, so Microsoft pushed very hard the Windows Mixed Reality story. All of their software now accepts 3D objects and files as basically as a first-class citizen.
Yeah, this is nice.
You can export this model for 3D printing, for example, from here. It's nice, but also it provides a preview. So we are running this lamp.
Yep.
And it's hidden somewhere. Let me take it on the stage. Where are you? Okay. Nice. We have a floor lamp. Going to add light again.
Yeah, that
Pixel
said it's for the HoloLens edition suites to Windows. Does anyone know much about the HoloLens 2? Do you know anybody who has a HoloLens 2?
I think Microsoft signed a contract with the military to equip them with HoloLenses, so they produced a huge number of units, but indie developers had hard times getting them. But this was before. I mean, we had the chance to work with HoloLens 2 on Microsoft build, and I really like the device. I mean, it's very lightweight, it's very comfortable, and
I played a lot with the HoloLens 1, and I mean, so the world, like the rendering was a little small. Like I wish it was a little more immersive, but I mean, you could see the promise, which I think they have fixed, and like what that Pixel is saying, these are really not meant for like consumer things. I mean, you can get the previews, and I think I saw somebody on Twitter that said, like, I mean, they have pre-ordered and maybe it will be available soon. So yeah, we don't know. But I mean, lots of like like very specialized enterprises who do testing. Definitely the military. I mean, they are into this. NASA got into the HoloLens one quite a bit. So yeah.
Yeah. If we put the military aside, the use cases I've seen are for assisted maintenance. You can basically enable the HoloLens to stream what you are viewing to a remote coworker, and he can give you guides on field. And another thing was for a training. There is an example by Bosch. They teach their workers to build, for example, engines by taking the 3D model of the engine, feeding it into the HoloLens, and the HoloLens will give a step-by-step guide how to assemble the engine. When you do it several times with the HoloLens, you eventually learn how to do it, and
you're better prepared. I mean, lots of implications like for like healthcare as well. And I mean, I can. I mean, you're modest, so you won't say it, but I can say it. But I mean, something that you and the team did was for like a local manufacturing plant for like safety standards, and people could get trained before they actually go walk out. So yeah. And Dead Pixel was saying you can buy the HoloLens. It's just expensive. It's not meant for like the average developer. It's for very specific usage.
Yeah, it's a little bit expensive, but I don't think that it is consumer ready. I wouldn't get it to use it at home. I mean, as an entertainment device, you can probably get I don't know, Xbox or something that's much cheaper, and there are more games for it. And you cannot watch high quality movies. TVs still beat it, but there are a lot of applications that cannot be done with other type of hardware. So it has
it does not make sense for a consumer. I mean, I know I'm distracting you, but like I'll say one last thing. So I used to be a gamer way back in the days, and then like life happened. But one of the things I used to play a lot was Half-Life. Right, and that was a PC game, and folks are I forget what it's called. Like if you have that Windows plugin and you have the Quest, there's like a Half-Life Alyx or something that's come up where you can actually play Half-Life or a variation of that in your Quest, which is very immersive. And maybe that's the future, where it is just like you're like so in the midst of it in a VR world. But I can imagine like that kind of first-person shooter game for too long. Like if the physics isn't right, that's gonna make you like puke or make you nauseating.
Yeah, but I actually have Half-Life, and I played it a lot, and it's very well done. I mean.
Wait a second. So Dead Pixel is saying it's actually out on the store. You don't even need to do that Windows hackish thing anymore. Okay. I gotta try that tonight. I did not know that.
Yeah. I mean, there was a delay in the deliveries at the early beginning after the announcement, so it was like for 6 months. We all speculated that they're just building stuff for the military, but they're available now. I think people started receiving them, so I think you can get HoloLens device. It's not that hard. I mean, it's available.
No, I mean, if you have the money, yes.
Yes, you can. If you have the money, yeah. Okay, so did you see what I did? I added 4 more lamps.
Yes, the floor lamp. 4.
Floor lamp. So hopefully this whole thing here will add some shadows on the point light, and again we need to change a bit the materials, so I'm going to extract them.
Yeah, I think Pana, we need to get you a green screen behind you, like a physical cloth green screen.
Okay, so there I'm getting a second monitor cable Wi-Fi, and I'm going to drop the Wi-Fi, I'm going to cable, and I can get a green screen.
Yeah, and really, like anything works. Like when I first started, it was just like a big, like a muslin cloth behind me, and that was fine.
My background is plain green at the moment, but it's pale like this one, and I tried to configure OBS to filter it, but
it's not an exact match. I mean, we can play around with the filters, but no, you're fine.
You can play around with the filters, but yeah, you cannot give it the color.
Yeah. It's hard, and it's unless you have like consistent lighting, it's not going to match on the exact filter. Yeah, it's an art.
Yeah, I can get a lighting well. Okay, good to know. So I want to make this tube material a little bit emissive, just a tiny bit, something like this, because it is not transparent. The tube is not transparent and will block the internal light, so it will appear very dark. It doesn't have a good way to make it semi-transparent, and at least I don't know a way to make it semi-transparent and leak partially light from inside. But making it emissive a little bit should be fine. Okay. Interesting color. Let's generate lightning again. Are you ready?
Yep, let's do it.
It takes too much time. I don't know why. Usually it takes about 2 minutes at most. I think it's set. This is baked. It has shadows. This is static, and the light static. It's starting to look well. I mean, we can see the texture on the floor now. We can see the ceiling is getting some indirectional light. I mean, the light from the lamps bounces on the really blue floor and then put some bluish tint on the ceiling, on the green part. The ceiling is a little bit greeny, so all of that it's a single plane with a single texture and color. The geometry around and the lights generate these variations that look very nice in there.
Yeah.
They basically add to the feel. This light here should throw. Okay, here it goes. Now, do you see the pattern on the floor?
Where?
Here, the floor map, the floor.
Oh, yeah. The shadow. Yes.
Will create these interesting patterns on the floor and on the wall.
That pixel is saying play the game, and while it's playing, move the light in the editor. So like the light spot will stay there on the floor.
They cannot. It takes a lot of time to generate the light maps. I can move the light, but basically as soon as I play it, I think this will pause.
I see.
But I think it's good enough to preview this in VR. Yeah, but okay. No, it's okay. So The frame rate is terrible at the moment. I'm not sure why. If I click play and enable the statistics, let's see if there are problems with the frame rate.
Well, you're also sharing a screen, so everything takes a load on the CPU.
Yeah, but it worked earlier, so it should be working at the moment. Maybe there may be problems. I mean, if I have forgotten to switch some of the lights from real time to baked, it may put a lot of pressure on the GPU. Okay,
Yep.
so here it's like insane. Okay, I'm going to put the quest device and
Crazy Kovacorn, thank you for the follow.
Okay, it's okay now, but
yeah, it looks better now.
No, it doesn't.
Huh?
This is the old light map. I mean, do you remember the light here on the wall?
Yeah.
It's not there. So maybe we interrupted the light generation.
Yeah.
I'm going to refresh the Unity editor for a while now. But yeah, basically there may be little problems with the lights here and there, but it's not something that we cannot fix. The lights will look interesting. There are things that are taken from the office. We have designed them to remind us of the office space. Maybe we should add a little bit more walls.
Can you put our Skype window, minimize it?
Why is it here? Okay. Yeah.
There you go.
Baking.
So does it give you like a progress of how much it's done? Like how do you know when it's done?
In the bottom right corner, there is
which you have like
baking.
Okay, I see.
It says 16 minutes, but it's length.
16 minutes.
Normally it takes about 2.
Okay. Yeah, I mean, I couldn't see that because like I have your face in the left corner, so I couldn't see.
Yeah. So, look, when I run this in VR, it was missing this kind of lights and shadows.
Yeah.
I mean, it makes the corners darker, and it's much more immersive that way. It just wasn't there.
Yep.
Maybe I shouldn't be interrupting it. Or maybe we should continue without the light map and just add the rest of the items that we want to add today.
Yeah. So let me ask you, like, what else have you dealt with in terms of like lighting that's troublesome in VR?
Well, since we work with the Oculus Quest, it's limited. I mean, it's a mobile device. So one of the things that you have to mind is how much textures you're using. If you use too much textures, you can throttle the GPU pipeline. So that's one of the reasons why most of the Oculus Quest games look like arcade games. Like they will have models and colors, but they will not have textures. There was an interesting use case for a healthcare application, for healthcare demo that we were working on. You basically wanted to make a human body that you can dissect, you can remove layers from the body and see the organs, but when we did that, it generated too much objects and draw calls. So it was a lot of effort to optimize it. So
yeah, I bet.
It's a general advice for the. It's a general advice. Just use a single dynamic light, and yeah, backlight maps.
Yeah, I remember when the HoloLens 1 had just come out, like they had a demo for a hospital which is actually near to me, Cleveland Clinic, and they had somebody just kind of go inside and dissect a human body and just take a look at the organs inside. And I bet like the lighting is like super difficult in those scenarios unless like you have like one fixed light from the top that does it. But yeah.
Yeah. Why is so slow? Oh, progressive CPU, that's why it's slow. It's not using my GPU. Do you see that? It was progressive CPU.
I'm just looking at. Oh, I see.
That's why it's slow, because I have like a good CPU, but the type of computations are like.
Yeah. We have to give you a name, Pana. Like you are like light. I don't know. Lightsaber Pana or something. Your face goes in and out.
Oh, this is a nice idea. We can do lightsabers.
Oh, okay.
Why not?
Yeah, it's great. For a social thing, we can just totally point the light at somebody's face. Do lightsabers.
Yeah, we can fight.
We can fight with lightsabers. Yes.
Did you see it? 2 minutes. Top. I mean, on the GPU it's way much faster.
Yeah,
and
yeah.
Look, now what happens? This light here at the bottom, basically, this one, points at the ceiling. So
yeah,
these are now throwing shadows.
Nice.
And also because most of the lights here will point down on the top of the columns, pretty darker. And you can now check it in VR, finally. Okay, so... Yeah. Do you see it?
Yeah, perfect. I see the lighting.
Okay, it looks nice now. I think that we are done with the lighting for today.
So once you take it off, I have a question. Like, how does look at that light where it's pointing toward like up a little bit? So it has a wall, and then it also points to the ceiling. Yeah, right there. How does Unity know to do that?
Unity knows that there is a light here.
Yeah.
And when you run the light map generation, it will get this light and will emit something like light particles. Basically, it will send something like small particles in all directions. Some of these will hit the inner side of the tube and will not go through it. And some of them will continue and hit the surface. Now, once they hit the surface, Unity will find where this surface is in the light map. You see here the yellow squares.
Yeah.
So it created this kind of picture that is dedicated for this wall, and all the particles that hit the wall will be represented here by making it a little bit lighter.
Got it.
And that's how we got this nice effect.
Yeah. Yeah, it's very nice.
Okay.
So is that kind of all you wanted to do with lighting in this room?
Yeah, I just wanted to add a preview of what we will be doing the next week.
Yeah. Oh, your face is completely gone now. No, you're back.
Okay, I'm definitely going to get a green screen, the non-AI green screen for the next session table, tennis table, for example. I'm not sure how to name it. Okay.
Ooh, ping pong. I like that.
Oh, ping pong. Yeah. Okay. So we have this that's going there. It's ping pong.
Nice.
You can up the table. It's somewhere under the ground. Okay, I'm going to position it here in the green space.
Love it.
And what I'm planning to do for the next time is we can add some colliders on these tables, bow, and start adding interaction system. I mean, it's now that we have part of the layout set here with the three-dimensional objects, it's not just floors. We can start adding functionality like walking around and interacting with these things. So I have the table tennis. I'm going to export the materials again. Extract. Okay. It should look like this. So let's try to fix the colors. This is the net. I think that we should modify it. The table tennis top maybe. Okay, yeah, it's that one. So
yeah, pretty close.
Yeah, I think that's it. Okay, we now have the scene and we can...
I love it.
Regenerate the lighting while we close. Now the tables, they should be static. Yes, change children.
I know it's getting late evening for you as well, Pana, so I mean, feel free to stop whenever you want. I mean, we did lighting today. We can...
No, basically that's it. I mean, this is the last thing that I wanted to show you. The tables will now generate shadows on the ground.
Nice. I like it.
So we have textures, we have walls, we can rearrange them as we see fit, and we have the table.
I like on the left hand side table, like since you have a light on the left, like it is, yeah, it's showing the lighting on the table, and plus then there's the shadow on the floor, but you don't have it obviously on the other one. Interesting.
I think that it's also broken. I'm not sure that there's no light that I think it's broken.
Like you get like two strips of lighting shadows on the table.
I think that the UV coordinates here are broken because there are two strips, but we don't have a light like that.
Yeah.
I just... Oh, okay.
Little baby steps. We made progress, so we can totally deal with this.
It's done.
All right. Cool. Is there anything else you want to show right now? Or, I mean, this is a good point to stop for the day.
This is a good point to stop. Next time we will add locomotion and interaction system, and we will start.
I love it. All right. Yeah. So folks in the chat room, we love you. As you know, Dead Pixel, thanks for helping out as always. I see actually one of my very good friends doing a live interview, like two of my close friends. So I might hand all of you folks over to Tail Learn Code. But thank you for hanging out with me, Pana. Thank you for teaching me as always. And have a nice day, nice evening, wherever you are, and we shall see you next time. All right. Bye-bye.
Thank you. Bye-bye.